Hey guys, it's Gene again. I'm a corporate pilot, captain on the Pilatus PC-12 Legacy and NG models, and I thought I would do a video walkthrough here of a Pilatus PC-12 startup and taxi and takeoff with initial climb. This is me. This is a video that I shot back in 2019, and I've had to blur out the N number placards and anything that's like identifying in the video because the operator that I flew for wanted anonymity for their clients, which is understandable, and that was in our contract, so I need to blur that stuff out so that you can't see the N number or like where we were exactly and all that kind of stuff. So anyway, but yeah, that's me. I'm in here in a Series 10 PC-12 Legacy, as you can see, and great airplane. And this is just going to be kind of a walkthrough of the steps. I'm going to pause it and explain everything I'm doing. So I'm going to start the video here, and there are just going to be a lot of pauses. So at this point I have my passengers loaded in the back, the doors are closed, the chocks are out, got the parking brake set, you can see right there. I do not have a ground marshal out front for this flight, so it's just me. And this is just a little airport out in the middle of nowhere, so there was no GPU available. So this is going to be a battery start. So you can see I've already turned on the battery. The avionics are powering up. I've got a bunch of stuff on the cause. You know, the engine isn't running yet or anything, and I'm just looking at the before start checklist to make sure I didn't miss anything. I've already done the flow, so I'm just going down that. Double checking things. So that's the EPS I just turned on. I already tested that before the first flight of the day, and I actually probably tested it again just, you know, before I started the camera. So the EPS is the emergency power supply, and that'll give you a little bit of, without going into all the details, of electrical power in the event of generator failure. So you can see the gear indicator there. We've got 3 green, a bunch of stuff, like I said, on the cause, and you'll notice that we have amber lights and 1 red light. Ambers are cautions, reds are warnings. So the red is really bad, and the caution is pretty bad. And let's see, I'm reaching up here for, that's the beacon light that I just turned on, and you can't see the entire overhead panel obviously, but you can see some of it. So we turn the beacon on to let anybody know that happens to be outside walking around the airplane that we're about to start the engine. And the PC-12 has an upper beacon and a lower beacon, so people should be able to see one or the other. Okay, and that's the start button right there. So this is starter interrupt, starter, and this is ignition, which is an auto. These are the fuel pumps above that. So you have to press and hold the starter button for at least 2 seconds to engage the starter motor, which I did. And then as soon as you release that button when the starter engages, you just move your hand over 1 button to the starter interrupt and you leave it there. And I didn't actually used to put my finger on it, as you can see, because I didn't want to accidentally press it. But I would just leave it just below so I could press that in a hurry if there was a malfunction or a hot start to cut the starter out. So I did a video on how to start the PC-12. You might want to check that out, and I'll walk through some of the steps here. But the first thing is to make sure the props turn, and that's easy. You can see that in your peripheral vision or look outside. There you go, props turning. I think I just glanced at it. So, and then I'm looking back inside now. Unfortunately, you can't see this stuff, which sucks because, you know, it's just not, the lighting isn't right. But up here is the NG. This is the ITT and the torque. And there's a bunch of other stuff on the EIS. This is the engine instrument system, this whole box or panel here. And we're checking to make sure first that the oil pressure is rising, which is right down here. And then the ITT is low enough for start, below 140 Celsius. And then we're checking the NG and just waiting to make sure that the NG stabilizes between 13 and 18%. We just let it motor up and then introduce fuel at ground idle after that. Before I did that, I would have checked the battery voltage, which I did before I started rolling the camera, to make sure we have at least 24 volts on the battery to start the engine. Otherwise, we could risk a hot start. So I'm just waiting for the engine to spool up. There, I just introduced fuel, moved the condition lever to ground idle, and we have light off. So as soon as you have fuel, when you introduce it, I mean, you look right here, and you can't see it. You can like barely maybe see some numbers right there, and that's the fuel flow. And you should have about 80 pounds per hour if everything's working as it should. If you have a lot more than that, you've got a problem, and you could get a hot start. And that's something that you practice in the simulator. You know, they'll throw different malfunctions and abnormal conditions and stuff at you, and hot starts and stuff. So It gets you in the habit of looking for that stuff early so that you don't overtemp the engine. And then as soon as you have light off, which means the engine has, the flame has lit off in the engine is spooling up, you're going to look at the, primarily at the ITT for a hot start, and you're going to make sure that it's not running away, it's not rising too rapidly, it's rising at a normal rate. And then you're going to look over here at the NG to make sure that that's also rising normally so that you don't have a hung start. So you're watching for a hot start here on the ITT and a hung start here on the NG. So I'm just watching those. And we're spooling up nicely. So you don't really have to do anything during the start other than just protect for the hot start. You're just monitoring. And then the starter will cut out at about 50% NG automatically if everything's working right. And there you go. So the NG is stable at about 63%, which is ground idle. And as soon as it's stable and the starter has cut out, you can bring your generators online. So I just turned on Gen 2, wait a minute for it to take some load, and then that's Gen 1 on, Avionics buses 1 and 2 on, standby bus off, and that's ECS to auto, flaps 15, and the cooling system on. So that was a lot of stuff that happened really fast, but basically, again, generators, Gen 2, wait a second, then Gen 1, Avionics buses 1 and 2 on, standby bus off. Come down here, turn your ECS to auto, that's the environmental control system, and that's what pressurizes the cabin, and it also adjusts the temperature in the cabin. And then what my hand is on right there is the temperature control knob for the ECS, and so you can dial in an appropriate cabin temperature on that knob. And then I also reached up, you couldn't see it, it's off frame on the overhead panel, but I turned on the cooling system. And the cooling system has 4 buttons. It's got basically the system on-off, cool or recirc, let's see, I'm trying to do this from memory, vent or vent plus flood, and then high or low. So it's basically just fan speed. So the vent fans are like the smaller fans in the cabin. The flood fan is a big fan in the back of the cabin that's really noisy, so we typically don't run that unless it's like super hot. Some owners don't like it run ever because it's just too noisy. And then you can turn the vent fans on high or low, and then cool or recirc. Recirc means recirculate, so that's no air conditioning. It's just fans or blowers just moving air through the cabin. And then the VCCS, which is the vapor cycle control system, is the air conditioning system on the airplane, which is actually in the hellhole in the tail. That if you turn it on cool, you're actually going to be running that, and you'll have air conditioned air coming into the cabin. And then, like I said, system on or off. So that air will come out of the overhead vents, the little twisty vents, just like you have on an airline jet in the back. And the ECS air from the engine bleed will actually come out of the floor vents. So reset the master caution in morning, and right there I hit the autopilot test button, and it didn't. You have to wait until it powers up to a certain point, and I don't think it took, so I'll have to hit that again. So I try it sometimes to see if it's ready yet, and if it's not, I'll just go back to it in a second. And then we've got, in this particular airplane, we had the GTN 650, 750, which are the really cool, nice touchscreen Garmin Avionics that are like drop-in replacements for the 430 and 530. And so I hit some buttons on there to initialize those. We've got an old Bendix King, the MFD down here. Getting the headset on, noise canceling on, and you can see, just tried the autopilot test again, it still wasn't ready. Hit continue on that. Testing the flight controls and the fuel caps as you're looking at the ailerons to make sure the fuel caps are on. There it went that time. And then I'm just initializing the avionics, typing in the flight plan, and transferring. I think maybe there was a database update there that I was loading in, maybe. And yeah, I'm just getting everything set up avionics wise. Twisted the heading bug around to probably the runway heading. Put that on the default nav page, making sure the CDI is set to GPS. I'm setting in my initial altitude. You can't really see it, but that's the altitude pre-selector. So that has 2 buttons and 2 knobs, so you dial in your initial altitude, and then you can arm that. And then on the PCL, which is the power control lever, which is the big black lever, it's like the throttle, There's a go around button, or a GA button, stands for go around. You would press that, and that actually commands your flight director to turn on and pitch up for a climb. It's like a 10-degree positive pitch. I think it's 10 to 12 degrees of positive pitch, and you can see that came up. And I also have that in heading mode. So on the autopilot control panel up here, I hit heading mode for that. So you always want to have your flight director ready to go before you take off, so that you can just pitch up into those command bars. And right there, I'm resetting the fuel. So once I move, there you go. Right there's the fuel reset button. You have to press and hold that for several seconds, and the sensors will take a new fuel reading in the tanks and give you an updated quantity right there. You do that before and after you start the engine and get the generators online, because it's actually calibrated at 28 volts. So you want to get the generators online and then reset that again to get the most accurate fuel quantity in there. And then I pulled the checklist out, and I'm just running through to make sure I didn't miss anything. So again, in larger, like in turbine airplanes, you always have a flow that you do, and then you back that up with a checklist. So the flow means you run through the procedure in your memory. You're flipping switches and getting stuff set through a flow through memory. And then after you do that, you pull the checklist out and you back it up to make sure you didn't miss anything. So the checklist is being used truly as a checklist, not a do list. And if you're flying two-pilot, then you'll each have flows. Typically in the PC-12, it's mostly just the pilot flying. And then the pilot monitoring will run the checklist using the challenge response method. So still just getting the GPS set up there and running through the checklist, double checking. It's a good idea to use your thumb to keep your place on the checklist so you don't miss anything there, especially single pilot. You got to be extra careful you don't have any omissions, because nobody's looking over your shoulder, so you got to be extra vigilant so you don't screw anything up. And yeah, doing the before taxi checklist here, I think. And here I'm probably going to do, this is the pusher test, which is a weird thing you have to do in the PC-12, because the stalling characteristics and the spin characteristics are not favorable in this airplane, so they actually put a stick shaker and pusher system on it, just like you would see in a larger jet, and to protect from a stall. So you do have to test that system before you take off, otherwise the airplane won't want you to take off. You'll have the pusher caution light here on the cause. So you have to, there's a button up here that says pusher, and you have to bump the PCL up to at least, I think it's at least like 5 psi of torque to clear a micro switch on the PCL. And then as you do that, you press and hold the button up here, bring the PCL back to idle so you're not running the engine up for no reason during the test. The shaker will start to shake the yoke, and then you pull the yoke back, and then the pusher will actually try to snatch the yoke out of your hands and push it, or push it forward. And then there's a red button right here, which is the pusher interrupt, and you press and hold that, and that will disengage the pusher, and then you pull the yoke back to make sure that you can override it. And then hold that button and release this button until you get a ding on the master caution, and then you can let it go and you've completed the test. It takes a little practice to get the flow right. So you can see it shaking there, and now it's going to push. There's the pusher, and I overrode it. Hold the button until you get the ding. There's the ding. Now you release, and you've got a successful test. So parking brake off, taxi light on, look around, clear left, forward, and right, reset the master caution, little breakaway power, start rolling. And I'm clicking the mic button to get the current altimeter setting there before I go. I probably already listened to that before I started the engine, but I'm just getting an update probably on this day, because I think this is probably... Yeah, I think that's what I did. Yeah, I just reset the altimeter there and the standby one down there. Now I'm making a call on the CTAF. And at this particular airport, there are no parallel taxiways or anything, so the runway's right here, and I'm going to back taxi for takeoff. So check in right, nobody's coming. Check in the left, final, the runway are clear. Turn all the lights on for a back taxi, the TCAS on to TA. Traffic advisory mode, just double checking, triple checking. And you see the yoke turning a little bit because there's a rudder aileron interconnect. So when you press on the rudder pedal, the yoke will actually turn with it as you taxi around. And I'm talking to myself here because I'm doing a departure briefing. And so again, single pilot, and even, you know, again, if you have a crew, you're going to do a departure briefing where you're going to brief, you know, hey, my takeoff, normal takeoff, flaps 15, runways dry, assigned heading up to 5,000, whatever the, you know, assigned altitude is, and then, you know, if we have any malfunction below 80 knots, you know, we reject, stay on the runway. Anything after 80 knots, we'll take it in the air. You go through a kind of a standard briefing format for every departure to make sure you're both on the same page. But even when you're flying single pilot, you still want to go through that briefing for yourself. You're a crew of one, so you just say it aloud and pretend like, you know, pretend like there are two of you there. So I'm just making sure I got that plan straight in my mind here, and then there's not much time to get it done at this airport, because like I said, you're just out on the runway and back taxiing and you're ready to go before you know it. So I'm probably checking to make sure the engine's warm and everything ready to go there, because I'm going to turn around at the end and blast off. So just running the taxi checklist, checking the battery charge, and yeah, we're pretty much ready to go, other than just a couple last items for takeoff. So you notice I switched hands there because I'm in beta, and typically in the PC-12 when you taxi, you're in beta most of the time just to keep the speed from building up too fast. And if you don't know what beta is, it's the opposite of alpha angle of attack. So beta means that the pitch of the propeller actually turns the other way, and you're getting a little bit of reverse thrust, and it really helps control your speed without riding the brakes as you taxi. Excuse me. And in the PC-12, as you taxi along in beta, the PCL is actually kind of spring-loaded to go back forward into alpha and over the beta gate into the idle detent. So you have to hold one hand on it at all times to keep it in beta. So if you need to use your right hand to do something like this, you got to put your left hand, you got to reach over on your left hand and just make sure the PCL doesn't creep forward out of beta. So you couldn't see what I did there, but I turned on the probe heat, the windshield heat left and right, both on light. That's standard stuff to get those going before takeoff, regardless of any, you know, icing conditions or anything like that. Those are just on every single time. And then I looked up, made sure the lights were on, and I'm running the before takeoff checklist to make sure I didn't miss anything. And I think the only thing left I have to do at this point, since the TCAS is on, is make a call on the CTAF, and I'm gonna, once I make the final turn to line up, so there's the call right there I'm making on the CTAF. Once I line up on the center line, or I'm coming around to the center line, I should say, I'm going to bring the condition lever up to flight idle right there. I just did it. And then checking to make sure that the cause is clear. So the cause is right here again, and you should make sure that you don't have any lights at all on. If you had any light, caution, or warning at that point, you would not want to take off. You'd want to get that resolved. So it's always a good idea to, as you line up on the departure runway, make sure that your heading matches what you expect it to if you can't see the markings. In this case, we can see the markings, so that's good enough. But, you know, you kind of always just do both. At least make sure your heading is, you know, in this case, it's 350. And, yeah, so ready to go. So at this point, what I'm going to do is ease the PCL up nice and slow until the prop comes into the governing range. So you can say, like some pilots say, I'm going to ease it up onto the governor, and that's what that means. If you go too fast through that governing range, the airplane will lurch, and it's not graceful at all. So you kind of have to ease it up till you feel the governor bite, and then from there you can push the PCL up a little bit faster to set your takeoff torque. So there's the governor right there, so I'm easing it up, and you can see the torque building right here. This is the torque. And so we want maximum torque for takeoff right below the red line. I know you can't see it that well, but it's approximately right there. And then just like any airplane, as soon as you get the takeoff power set, you're checking to make sure that your gauges look normal and that your airspeed is alive. So a couple quick checks, make sure those look good. Tracking the center line, and then we're going to rotate at 80 knots. Comes up fast in the PC-12. It accelerates quite well. So there I'm just rotating, and we've got a positive rate, so I tapped the brakes, selected gear up, yaw damp on, taxi and landing lights off. So that's the standard flow that they teach you in the simulator. Flight safety, the yaw damp comes on right away, and then you reach up and turn off the taxi and landing lights, because those are actually on the landing gear struts. So as the gear comes up into the wells, you don't want those lights burning in the wells. There is a micro switch that should turn those off automatically, but you know, just in case it fails, you go ahead and switch those lights off. And I'm flying the profile, so VY is about 120, and of course depends on altitude and weight and all that good stuff. And then I just put the flaps up. So at 400 feet radar altitude, which is right there, you can see it says 420. I think it's hard for me to see too. I think it says 420, and at least 100 knots. And as long as you know you feel nice and stable, you'll go ahead and bring the flaps up at that point. And we're going to climb at VY, so I just flew the departure leg, and I departed VFR here. I'm going to pick my clearance up en route. So I'm just making a left-hand turn on course, a left turn out here. So you climb at VY to 1,000 feet AGL, and then at that point you'll accelerate to 150 knot cruise climb and bring your power back to climb power. Which is maximum 36.9 psi, or just the top of the green arc on the torque gauge. And then you'll cruise climb at 150 knots all the way up to 18,000 feet, and then you'll do 140 knots from between 18 and 22 if you're going that high, and then if you go above 22, you'll cruise climb at 130 knots indicated. Another thing I wanted to show you was the trim. You can see that my index finger there is actually on a trigger. There's a little trigger on that side of the yoke that you have to pull to activate the trim system, and then or to arm it. And then this little hat switch, just like on your flight sim yoke, it doesn't control your view, it controls your trim. So up and down is your stab trim or your stabilizer trim, which is nose up and down, pitch trim. And then left and right is your aileron trim. And then on the PCL, on the front side of the PCL, there's a little trigger. That's a little, like a rocker switch. For left and right, and that's your rudder trim. So I'm just trimming it out there for climb. PC-12 is an absolute joy to fly. It's very heavy in all three axes, pitch, roll, and yaw. The Legacy is, the NG is not. They fixed it with a Flettner tab on the aileron. But the PC-12 is pretty heavy. The Legacy is pretty heavy. But you know, you get used to it and you trim it up, and it just feels nice and solid in your hands. It's a lot of fun to fly. So just adjusted the heading bug there, switched from the CTAF over to center, and I'm going to get my frequency, or my clearance there, my IFR clearance. So I'm just getting ready to talk to them, and at that point, yeah, they're going to give me a beacon code and give me radar identified, and I'm just going to climb up, run the after takeoff checklist, and then so I'm reaching down to the transponder to punch in the beacon code they just gave me there, and yeah, up and away we go. So anyway, that's it for now. If you have any questions for me, as always, please leave those in the comments. I love hearing from people, and please consider subscribing if you like this kind of stuff. And I will see you guys on the next one. Thanks.